Okay, good morning, everyone. I think, yeah, we've kind of peaked in terms of people joining, so let's jump into it. Yeah, just wanted to welcome everybody to this demo today for printing biomedical sensors. Yeah, before we jump into the meat of it, I'll just go over the plan for the next hour. So for today's demo, we're going to be printing with Creative Materials 124-36, which is a silver chloride ink. And we're going to be printing that onto a TPU substrate. Before we jump into the print, I'm going to go over silver chloride as a material and why it's used so widely in biomedical applications. We'll talk about advantages of printing a sensor and what to think about when choosing an ink for printing a sensor. And then we'll take a closer look at the ink we're using today, specifically from Creative Materials, and then we'll finish off with the print. Yeah, and before I start with the presentation, feel free to ask any questions you have throughout the presentation. In the chat, we have Gio and Tom from Volterra there, and we also have Dan and Matthew from Creative Materials at the ready to help answer questions as well. And if anything isn't answered during the presentation, feel free to reach out afterwards to us at hello@volterra.io, and you can reach Creative Materials atlallen at creativematerials.com. Cool. So yeah, without further ado, I will jump into the presentation side of things. Yeah, so today we're going to be talking about silver chloride and why it's a good material for biosensors. We're going to look at some traditional silver chloride sensors, go over the pros and cons of those, and then we're going to kind of shift into why you might want to print a sensor and why this is a good direction to go into. We'll talk about choosing an ink for printing a biosensor, and then we'll look at, the material we're using today for our print demo. So, silver chloride as a material. So some of the reasons why it's so widely used in biomedical applications is it has a low skin to electrode impedance. So this means that you're going to get good quality signals from the skin that you can use for a wide variety of applications. It presents low frequency noise, especially compared to just gold or regular silver electrodes, which is really great for a low power circuit. It can be used in a wide temperature range, and you can see the advantages of that when we're applying it to the skin in different environments. Yeah, just being able to use these in a different temperature range is really great as well. And it opens it up to a lot of different post-curing methods as well. And it's just got a very stable electrochemical potential. So again, this leads to stability and reliability and just consistency in the sensors that you're building. And I mean, one of the biggest pieces is it's non-toxic and environmentally friendly. So yeah, you don't have to worry about the effect it's going to have on somebody wearing this or the environment going forward. And the other piece is it's just a very robust material. Like we mentioned, it's very stable, but yeah, it's also a very strong chemical bond. So some of the medical applications for silver chloride, these are very widely used for EKG, EEG, ECG style sensors. They're used for defibrillator pads. We see them in glucose monitors, and we also see them for drug delivery devices. So yeah, anything that's got to make skin contact, this material is a great way of transmitting that signal between the body and whatever sensing device you have. So when it comes to traditional silver chloride sensors. We just looked at a couple examples, but these are probably the most common that people are used to seeing, these Philips style with the button connector. So some of the pros to using these types of sensors is they're just readily available. They're cheap. You can buy them in bulk. You don't have to worry about what you're going to do with them. Easy to dispose of. And yeah, they have a really robust connection with that button style connector. And a lot of the tech is built for connecting with those. But some of the cons is they're susceptible to motion artifacts. So if the wearer isn't kept really still, you can actually see any motion of the wearer in the data from the sensors. They can be really uncomfortable for the wearer, especially when you are pulling them off because they have a fairly strong adhesive. And because of that, they're also unsuitable for long-term use. So they're good for a quick couple of tests, maybe wearing for an hour or two, but this isn't good for a long-term use, like over testing over the course of a full day or maybe 2 days. And the other bit with these traditional kind of over-the-shelf sensors is they are difficult to customize. You pretty much get what you get. There are a different variation of options in terms of sensitivity and conductivity, but you're pretty much stuck with the options you can buy. So that leads us to why you might want to print a sensor, and you might see where we're heading here. So one of the main reasons you might want to print a sensor instead of just buy an off-the-shelf one is it fits seamlessly with the body. This means they're more comfortable for the wearer because it's molded to their body. It's not something that's just stuck onto them. It's more flexible with body movement, which means this can be worn a lot longer. And they're actually more efficient. And they're more efficient because we can personalize them to the wearer. This comes into personalization of the pattern itself. So the personalization can be designing a design that's unique for your testing application, but it can also be personalized to the material that you need to use. So if you need a different ratio of silver to silver chloride, there's a lot wider margin and options for you there. But yeah, and again, you can personalize it to the actual anatomy of the person that sensor will go onto. And super non-invasive. So yeah, these will be applied and come off the wearer a lot more easily. So if you're interested in a bit more information about silver chloride applications, I just wanted to throw out a bit of a plug for our blog. We do have a silver chloride blog post on our Volterra.io website. And you can navigate to that by just going to Volterra.io, clicking on the resources in the menu and then selecting blog. And then you should be able to scroll down to silver chloride. But yeah, we've got a lot more detail into the different types of applications as well for it there. So let's jump into choosing an ink and the things you might want to consider thinking about there. So yeah, things to consider for your application specifically if you're going to print a silver chloride sensor. So the first thing mainly you want to think about is what is the silver to silver chloride ratio. So you can adjust these ratios within the material, and based on those adjustments, you're going to get different levels of conductivity and different levels of sensitivity for your circuit. You also want to think about what is going to be the application method of this material. Am I going to be screen printing this? Am I going to be dispensing it like on Nova? Or am I going to be stamping, dipping? This comes into play with the type of material you might want to get if it's suitable for that application. You're also going to want to look at what you're going to be printing or applying this ink to in terms of a substrate. Is it going to be a Kapton? Is it glass, polyamide? Is it TPU, polyester? All these different substrates have different levels of adhesion and might play nice with some inks and might not play nice with other inks. So it's important to think about what substrate you're planning on using for your project or your application. And finally, what resin type is made up in the ink. So pretty much all of the inks we work with have different types of resin to help cure the ink in the end. So this is more important on just what curing method do you need to use. Are you specifically needing to avoid heat altogether? In which case you might want a resin type that can be UV cured, or yeah, do you have a specific temperature range that you can work with? That might affect what you're choosing for your ink. So these are kind of the four main things you want to look at when choosing a silver chloride ink. So again, it's what's the ratio of the silver to silver chloride, what application method are you going to be using, what substrate is it going onto, and then, yeah, what is going to be the resin type, or thinking about what curing method you're going to use. So I'm just giving you an example since we're working with a creative materials ink today. So this is just kind of screenshotted from their website. This is not the exhaustive list of all the silver chloride inks they have. There's probably 3 times as many as this, but I just wanted to give you kind of a good example of how they have things laid out and how choosing an ink, you can use this table to easily kind of navigate those through those 4 choices. So they have the silver chloride ratio listed here beside each ink. So if you need something that's really heavy on the silver end and not so much on the silver chloride end, you could look at something like the 125-20. But if you need something that's a little more balanced, they have more balanced options as well. Then, like I mentioned, we're looking at conductivity. So if you have a specific conductivity requirement for your project, you can shop based on that as well. They have the application method listed here. These ones are all listed as mainly screen printing, but they do have some further down for different applications as well on their website. And then you can use the description to kind of look at what is kind of like the key selling point of this ink. And a lot of times it's how it's going to play with either a substrate or a curing method as well. So we can see some of these are chemically resistant electrode inks. Some of these are water-borne electrode inks. Some of these are just kind of standard for defibrillation and reference electrodes. So lots of really great detail there. And of course, you can click on their website on any of the actual product numbers as well to open up the technical data sheets, which goes into a lot more info, and there's a lot more details for you there. So for the material we're using today, the Creative Materials 124-36, this is listed as just a standard electrode ink. So just giving you a little bit more detail on this ink. So they have it listed, yeah, as a medical grade electrically conductive ink, coating and adhesive. It has a variety of application methods: stamping, screen printing, dipping, and syringe dispensing. It's got excellent adhesion for a wide range of substrates, and it's very resistant to flexing and creasing. So it holds up really nicely after it's been printed and cured. So some of the applications that Creative Materials has listed for this ink specifically is for EKG and TENS electrodes, for EMI and RFI shielding for polyimide flex circuits, which is a really cool application as well. General thick film circuits, and membrane switches, which is really cool to see also. So these are kind of the reasons why we chose to go with the 124-36 from Creative Materials today. The viscosity range is listed as screen printable, but it's in the 17 to 23K centipoise scale. And this matches up really well with a range that works well with Nova. In terms of our project, the silver chloride ratio provides us with a good conductivity level that we're looking for. And then the cure temperature for this ink is 100 degrees Celsius for a few minutes, which is super easy for us to hit with our curing equipment. Again, this has excellent crease resistance. So as a wearable application, this is going to hold up to bending and conforming around the body. And this one's really great because we're printing onto TPU today, which usually requires lamination. This ink, once cured, has thermal stability up to 325 degrees Celsius plus. So we are going to have a great time laminating our TPU to fabric or something else once we're done our print. So yeah, that's why we kind of went with this ink. So Just a quick plug for Creative Materials. Again, we've got Dan and Matthew in the chat today to answer your questions. But yeah, if you don't get to it in the chat or you want to reach out afterwards, they have requested that you reach out to lallen@creativematerials.com. And I think Mal will be posting that email in the chat for you guys as well. Yeah, so if you have any questions for Creative Materials specifically about their different types of silver chloride materials or their other great range of materials, feel free to directly ask them in the chat or reach out afterwards. Cool. So why don't we jump into our print demo? Cool. So I'm moving just right into the software. Cool. So today we're just going to be doing a regular print. We're going to be printing our Creative Materials 124-36 onto a TPU substrate. I have these materials already set up in my library, so I'm going to start by just jumping right into the dispense workflow. Perfect. So for today, I'm just doing a one-off print, so I don't need to worry about the create a job section, so I can just move on right away. And I'm prompted to select my materials. And I should note, yeah, if you're not familiar with the V1 or the Nova software, we basically have all the user interface inputs happening here on the left-hand side. Your work area is going to be dead center, and we'll be working with that throughout today's print. And then on the right-hand side, we often have some useful help materials as well. So just tips and tricks as you're going through the process, things to walk you through a little bit more. So for today, we need to choose our materials. So we're prompted to select a paste and a substrate that we want to dispense with. So I already have my Creative Materials 124-36 here. So I will select that. And then I have my TPU set up as well. So I'm ready to select that. Cool. So with those selected, I'm allowed to click next and I'm prompted to load a pattern. So I can just click choose file and select something from my computer. So I've got a biosensor file here ready to go. So I'll just click open. And we're going to see that we're generating toolpaths for the file. And this is where we'll see kind of all the working messages for Nova as they're happening. And we can see our circuit loading in here in the center of our screen. And once it goes green, we know that all the tool paths have been created, and we can zoom in and see those tool paths a little more clearly if we want. We can right click and drag around to move around the image itself. But yeah, I think everything loaded in here great for us today. So I am going to click next. Perfect. So you can see we're being prompted to mount our substrate. In this case, we had set up our TPU as a flexible substrate. So we are being prompted to mount the vacuum module and then put our substrate on top of that. So I'm just going to grab our vacuum module and do that here. So the vacuum module, yeah, it's a silver it's a titanium porous plate. And on the back side, we have 4 vacuum ports, and that's how we get the suction. And it just slides in place into our work area here and registers really nicely. So it's easy to just drop into place, and then it's loaded up. And so all I have to do now is grab a sheet of TPU and place it onto my work area. Now I've got a fairly large sheet of TPU here today that covers pretty much all of my vacuum bed. So I'm going to have great suction, so I don't need to worry about that. But if I was using a smaller sheet of TPU, maybe just a little kind of couple inch by couple inch quarter, I'm probably not going to get as great suction across the whole other area of the bed. So a great suggestion for that, if you're using smaller pieces of substrate on the vacuum module, is just to mask off the rest of the vacuum module with either some paper or some tape. We've even had customers use cling film, and that has worked really well as well. But like I said, today I've got a fairly large piece here, so I should have great suction. So with our substrate mounted, I can jump back to the software here and just click next. So the next step is we're going to be aligning our circuit to our workpiece, our substrate. And for that, today, I mean, I've got a big blank workpiece, and I have nothing I need to specifically align to, but we'll still go through the alignment process just so you can see it here. So for the alignment process, we've got kind of 3 steps. We're going to set a pivot point, set the pivot position, and set the rotation of our circuit. So for setting the pivot point, basically what we're doing is we're selecting a part of our circuit. We can click and select any part of our circuit. When we're setting the pivot point, this is basically the point of our circuit that we're going to be doing our movement around. So we will move our circuit based on this single point, and we'll see that in a second. And then this is also going to be the point in which we rotate our circuit around. So that'll be clear in a second here as well. So I can select, like I said, any point on my circuit as the pivot point, but I might go for one of these larger circles. So with that set, now I can set the pivot position. So the camera is just going to quickly home itself. So we can see that happening here as well. So it's centering itself on the circle. And you can see now that we're doing proper alignment, the vacuum has engaged, so our substrate can't move around any further. So I'm not expecting to see much here on the camera, so I'm going to actually just swap to the background using the swap background button here in a second. Perfect. And we can see how the pivot point works. So again, we selected this circle as our pivot point, and now I can use the arrow keys to move our circuit around based on that point. So I'm moving it to the left currently. I can move it up. If I want to change the step size, I can click in the center of the arrow keys to adjust the step size. So now we're down to 1 millimeter, so it's moving in smaller increments. And we can keep going down until we're moving very, very, very small amounts. And this is great when you need to align to something specific. Perfect. And we can also see in our camera view that we do have an AR overlay here of our printed circuit. So when you're aligning to something specific, that's really nice because you can see where it's going to be printing. Yeah, so with our position in place, I think I like this spot. We can move to the set rotation. So again, like I said, this is going to be the point in which our circuit rotates around. And now we've got 2 arrows for rotating clockwise or counterclockwise. And you can see that our circuit is pivoting around this point specifically. And it can go all the way around. We can also open up the advanced settings and set a specific setting. So if I want it to be completely 180 degrees upside down, we can do that. If we want it to be 270, we can do that. If we want it to be 90, we have that option as well. Or if we want to just reset it, we can go back to 0. But you always have the option to go to simple. And with simple, we do have the option to change the step size here as well. So you can just click in the center to adjust that step size. Perfect. But yeah, for today, I think I'm happy with this position. Again, I'm printing onto a blank piece of substrate, so I don't have to worry about too much with alignment. So I'm able to just click next. And here's where we can tune alignment. Even though we're not aligning to anything specific, I do recommend doing a quick tune alignment just to make sure that we are printing onto our substrate, especially if you're using a smaller piece of substrate, just to make sure that nothing's going to fall off the edge. You should be able to notice that in the probing step, but saves you a second of having to go back. So our camera is just going to take a couple of pictures across the area of our circuit in a couple different spots. And yeah, it will give us the option to tune the alignment after those pictures have been taken. But for today, we're just basically checking to make sure that there's substrate below the areas that we are printing on. Perfect. So I think it's just taking one more photo. Again, I'm not expecting to see much here because we're working with a completely blank substrate. But if you had a couple other prints maybe on the substrate or had something you specifically wanted to align to, this is a good way to check things out. Perfect. So we've got uh, an idea on our map here of where these photos were taken. So we got the four corners, which is really great for our edge guidance to make sure that we're not going off the edge anywhere and nothing is being missed. But yeah, everything looks even. I'm not seeing a line coming through where our substrate's ending or anything like that. But if I needed, I could also tune the alignment here. You can see I've got the rotation and movement options again. But I think for today, I'm ready to move on to the next step. And that next step is probing. This is a great opportunity to showcase a small little feature from our latest software update, version 1.7. You can see I have to check the box indicating my calibration plate is clean before I'm allowed to probe. And this is mainly because we probe both the substrate and the calibration area because we're going to be doing a flow check on the calibration area as well. So I'm just going to do a quick check, make sure it's clean. Yeah, looks good to me. I'm able to select that. And now we're able to hit the probe option. So while we're probing here, you can see Nova is going to be checking the probe with the XYZ positioner tool. So this is so we can get the precise position of the probe in our 3D space. So in our X, our Y, and our Z axis. So you can see it went down and touched the middle of the probe first. That was to get its Z height. And then it's kind of touching on either side, kind of in a north, south, east, west kind of direction. And that's how we find the center of the tool in the X-axis and the center of the tool in the Y-axis. So once that's registered, we can move over to the calibration plate and start probing. Perfect. And once it's done with the calibration area, I'll jump back to the software to show as it's probing. Actually, I'll go multi-view here. So you can see the probing happening live on our circuit here as well. So as a point gets probed, we can see it get filled in here. And you can see we're not probing literally every small, tiny nuance of our circuit. This is set by a probe pitch setting in our substrate settings. And so basically we are constantly with a balance of accuracy and time savings. So the general probe pitch setting is 5 millimeters, which is saying the maximum distance between two probing points in a design can be 5 millimeters. And that we found that's a good balance between really good height accuracy, but also not spending too much time. If that's something where you do need a really height accurate map, you can always reduce that probe pitch setting so that there are more probing points generated and you get a more accurate height map. You just got to spend a little more time in the probing step for that. And so basically what we're doing is we're interpolating the data between probing points and creating a bunch of little triangles and making sure that there's no massive changes between those triangles. But yeah, and we're able to interpolate between the triangles to generate the rest of the height. We also have our progress bar here on the left-hand side in our menu. So you can see we're just about 3/4 or 2/3 of the way through, almost 3/4. can jump to Nova for the last couple of probing points, just so you can see it in action. So we can see every time that Nova's smart probe is making contact, we're seeing the little light up. So that's just letting us know that it's sensed the point. So just a little bit of a visual contact for us. It does look white on the camera, but it is blue in real life. Perfect. Last couple of points there, and we are all done. So the gantry is just going to move back to its home position once done, and we can jump back to the software here. So yeah, I think we're pretty happy with how everything probed, so we can move on to the next step. So the next step is we're getting ready for printing here. So we are getting instructions on how to assemble and disassemble and clean the pressure sensor on our dispenser. And we've got some guides here on the right-hand side. We also have some great support articles on how to do these in more detail, and that's just at docs.volterra.io, docs.volterra.io. And we have got some great walkthroughs on assembling the dispenser, disassembling, cleaning, general maintenance, all that kind of stuff. So it's a great resource for you. In my case, I already have the dispenser assembled and attached to the machine. So I'm just going to move to the next step, which is our flow check. So the flow check, we're not doing a calibration here. We already have our ink settings dialed in. So all we're doing is we want to make sure that ink is coming out of the nozzle before we start printing onto our substrate. Otherwise, who knows where at the start, where the start of the print will begin in printing our pattern. So I'm just going to click check here. And we can see Nova is going to interact with the Smart Dispenser this time to get its position in X, Y, and Z. So it's doing the same thing as a probe. It's getting the Z height there first. Now it's moving in X to find the center. And now it's moving in Y, touching on both sides of the thumb screw to get its position there. And then it'll just do a double check there. So I just saw a quick question in the chat. What size and nozzle color are we using here? We're using some Nordson EDF nozzles, and this size is a 200 micron. It's a straight barrel geometry, and these are actually newly added to our store just this past week. So you can check out our store at store.volterra.io, and these are under the consumables section. So those are available to you all there as well. So in the software, we do have ink coming out in our first check. It's just here in the bottom left here. I could do another check just to double check, but we basically just want to make sure ink's flowing here. So again, Nova goes and takes a picture so that you don't have to go in there and look with your own eye. But yeah, we've definitely got flow coming out of our nozzle here. So yeah, we're good to move on to actually printing our pattern. Now, throughout our pattern print, we still have the option to adjust our main pressure settings. So the dispense pressure. So if we notice a couple of features maybe are a bit sparse or a little bit too heavy, we can always adjust the flow. And we have kind of 3 different levels we can adjust it by in terms of severity. So 100 will adjust the dispense setting by 100 points here. So if I were to go up, it would go up to 1180. If I were to go down, it'd go down to 980. But similarly, we can go to a smaller adjustment size by 20, or really drastic 500 as well. And we can do the same for our relief pressure here. So just for example, I can just click up or click down at any time during our print to adjust those settings. The other thing we can do in this section is if we don't want to print the whole print, or we want to see how just a portion of the print's going to work, we can always just click and drag and select some of the features from our design. So we don't always have to select everything. We can just select individual features by clicking on them. We can do group selects with a big box around it. And that's what this help tutorial in the right hand is talking about here. But for today, I do want to print the whole thing. So I'm going to select the whole thing. And we can see it's all green, so it's all been selected. And then I just have to click Start for it to start printing the pattern. So I'll jump over to our Nova view for that. So I timed this print a little bit earlier. It takes about 7 minutes to go through. So yeah, this is a great chance to toss in questions into the chat for Gio, Tom, and Dan and Matt from Creative Materials as well. And if we look at our software, we can also see here, we've got a little bit of a progress bar in the left-hand side here of how far we are in our print. But we also get visual representation of what parts of our print have been printed already by them becoming deselected. So we've already printed these two larger traces here. And I think we are working on this one right now. So once it's complete, it will go blue here as well. So we're just working on this final trace here on the left. And then Nova's going to work on infilling all the circular pads. So this is a great way to highlight one of the features of Nova that's a big step up from the V1 specifically. Because we have the pressure sensor, we can provide constant pressure to our material and understand what pressure setting we're at. So typically when printing circles like this on the V1, you'll often see the V1 have to start, re-add some pressure, and then continue printing. Whereas with Nova, circles like this, we can just continue printing basically until our ink runs out. So yeah, this is a really nice feature with Nova. And I'm just keeping an eye on how our circles are filling in. From here, they're looking good right now. We can always inspect the print afterwards with the onboard camera. But yeah, this is a great chance to dial in the flow settings if they need to change by any amount. And this is where additive electronics is really great. Yeah, if we notice that we want to fine tune something after this print, we can just make those adjustments in our settings, and we can print another variation right next alongside this one immediately without having to go back and redesign anything. So if we want more overlap between our trace spaces, we can do that in our settings. If we want to slow down the speed we're printing with, we can do that. Again, yeah, if we want to add more flow or take away some of the flow, we can do that at any point here during this print, but you can also do that for a subsequent print as well. Yeah, I guess one thing we noticed while I was doing some test prints for this for yesterday is overall it was getting really good flow, but I was noticing just some small pockets that were missing. And after a couple of test prints, we decided it might be time just for our ink to go through the mixer again. There might have been some air bubbles in there or something that had appeared. So yeah, sometimes just remixing your material to get rid of those air bubbles and then going back to print can make all the difference. And while we're just doing the print here, I'm just going to clean my calibration plate. I always like to clean as I go so that I can keep this machine running as smoothly and as well as it can. So yeah, just a quick wipe up and then some isopropyl alcohol to clean up the area. And I've got a clean calibration plate again. Yeah, this print is looking really good so far from here. Yeah, and we're on just the last pad here of our 6 pads. And I will say, just as a note, you never get bored of watching, the print. Yeah, it's just a bit mesmerizing. It's cool to see something come to life out of nothing. That's one of the really cool bits of additive manufacturing for sure. All right, it's just finishing its last couple traces. There we go. It is all done. So I'm just going to jump back to the software fully here. So yeah, our print's all finished here. If we notice that maybe this pad was looking very poor, we could always try and wipe it off and then try and reprint just that pad. But for today, I think we're just going to go to inspect our print. So when we click on the inspect print, we do get the arrow keys. And I will mention that it defaults to 50, which is a pretty big step. So that's going to be 5 centimeters. So 50 millimeters. So you can change that step amount that you're going to move. But the other option you can do is you can always just click in the work area as well to move the camera to that spot. So yeah, we can just start by clicking on one of these pads and it'll move the camera directly there. Now, if I don't like looking at the camera just in this bottom corner, I can always swap the background. And so we've got, yeah, the option to inspect our print here. it's looking pretty well in focus right now, and this is looking like a fairly good print. But if I needed to, I can always autofocus the camera here as well, and it'll just quickly refocus itself. We can also change the color of the light. Again, we're printing a silver ink onto a gray background, so the contrast might not always be great. So we can cycle through the colors or turn the light off altogether to get a better view. Yeah, and we can go full screen with this as well. And yeah, but yeah, if we want to move around, we can jump back here, use the arrow keys to move around our design. We can swap back to, and we can click anywhere in our design to move to that spot. So if I want to inspect all of my electrode pads here, I can just click them one at a time. I'll turn the lights back on here just so we get a little bit more contrast. But yeah, we can go through each one of our pads, make sure they're looking even and filled. We can go look through each of the traces to make sure that there's no gaps missing. But yeah, I think for today's print, I am pretty happy with this. Sarah, one of our co-ops here, who actually designed this circuit, she just said solid print to me in our internal messaging. So we're pleased with this. So we're able to move on, and then we're just able to give some quick feedback of how our print well. So either it went well or it did, or something went wrong. Today it went well, so I'm happy to click that. And then we're given the option to save the job at the end here as well. So we can save our circuit, our paste, our substrate, and our alignment. So if this is something we want to be fairly repetitive about, we can save this as a job and then be able to call that up when we're starting the dispense workflow at the very start, and it'll load up these 4 things for us automatically. But for today, I'm just going to leave it as is and click finish. And our vacuum goes out. I don't know how well the vacuum comes across my microphone, hopefully not too loud. But here we go. So I'm just going to jump here and to this camera, just so I can show the print a little closer to the camera here as well for you guys. So I'll try and hold it on an angle where you can get a little bit more contrast. But yeah, you can see we got a really good print today. So I'll take some pictures, and we can include this in our post webinar email as well. But yeah, I think for today, that pretty much wraps everything up. So I just wanted to thank everybody for attending. Like I just mentioned, we'll be sending out a follow-up email to everyone who signed up for the webinar. So even if folks aren't here, they'll be getting that email. And in it, we'll be including a link to the recording of the webinar for today. So you'll have access to that beyond just today as well. And if you have any follow-up questions and you'd like to get in touch with us or Creative Materials, like I mentioned earlier, you can send us an email at hello@volterra.io. And if you'd like to get in touch with Creative Materials, you can email them at Allen, so Lallen @creativematerials.com. Yeah, so just want to thank everybody and have a great rest of your day.